Okay, now we will start.
स्वतंत्र रव अमृत मंत्र नव प्रिय स्वतंत्र रव अमृत मंत्र नव भारत में भर दे वर देवी नावादिनी वर दे वर देवी नावादिनी वर दे काट अंधौर ये बंधन स्तर काट अंधौर ये बंधन स्तर बहाजननी ज्योतिर्मय निर्झर बहाजननी ज्योतिर्मय निर्झर कलुष भेद तम हर प्रकाश भर जगमग जग कर दे वर देवी नावादिनी वर दे वर देवी ना वर देवी ना वर देवी नावादिनी वर दे.
Thank you, Shefali Chuturvedi. Now I will brief our IIRO. Now I will brief our today's speaker, Dr. Anjali Milind Naik, ma'am. She did her B in Computer Science Engineering from Bharati Vidyapeeth, Pune, Maharashtra in 1992. She joined in computer department of Cummins College of Engineering for Women's Pune in 1994. After that, she also completed her ME from Government College of Engineering, Pune. She also did PhD from Bharat Institute of Higher Education and Research, Chennai. She is teaching subjects like computer programming, data science, discrete mathematics, artificial intelligence, soft computing, artificial neural network. She also published 9 research papers in area of machine learning. She is currently working as assistant professor in computer engineering department, Cummins College, Pune. So I will request Dr. Anjali Madam to share her PPT and start presentation. Ma'am, I am stopping my PPT. Now please you share your PPT, madam.
Okay. Am I audible right now?
Yeah, madam.
Okay. Now I will try to share the screen.
Yes, madam.
So I have to select the window or the entire screen?
You can select actual PPT, madam, or if you are unable, you
Okay.
please select the all.
Okay, okay.
And you please select this green button, share screen.
Okay.
Yes, madam. Your screen is now visible.
Okay, just a minute.
Yeah. Please take time comfortably.
Yes.
You please present.
Now, till I join, as there are very few participants, I want to ask the background for each of the participant. Can participants tell me their background?
Basically, madam, our this presentation also actually very much like in the YouTube, madam. Many students and the faculty are actually seeing this all by the video also, madam. So you can ask anyone.
Okay. Can I talk to Priyanka, Santosh?
Please, Santosh. Yeah, Santosh. Please unmute from yourself. Santosh Sahu. Please unmute from yourself, or Priyanka. Priyanka, you please
Yes,
unmute.
sir.
Priyanka, please unmute from yourself.
Yes, sir.
Yes, please.
Can I know your background?
Yeah.
Hello, ma'am. Myself Priyanka Masi, and I am a PhD scholar in Maths University.
Okay. So which is your area?
My area is IT, Information
Okay.
Technology, Computer Science.
So discrete mathematics is required for you?
I just want to know the basic of set theory and relationship. That's why I joined this group.
Okay, fine, fine.
Okay.
Okay.
Yes.
So
Yes.
Santosh is there?
Santosh, please. Are you online? Santosh Sahu.
Okay, fine.
Okay, madam.
Dubey sir, I think I will start my lecture.
Yeah, madam. Yeah, please, madam. Please.
Now, set theory and relations, these are two important topics. And mm, you have studied these topics in 11th standard and 12th standard for JEE and various competitive exams. Also for aptitude test, these two topics are very important. As far as engineering areas are concerned, in computer and IT, there is separate subject called as discrete mathematics. Then these topics, this is the base of the programming and the databases. So with the set theory and various operations, you can design multiple programming concepts useful for application development. So let us begin the topic. In 1 hour, explaining all sets and relations may be a little difficult. So I have tried covering only the basics, and if possible, I will be sharing what type of problems are asked or what type of problems are solved. In between, if you feel, you can ask me the question. So sets, subsets. So under sets, what comes is sets, subsets, then universal sets, empty sets, then algebra of sets and duality concept, operations on sets, so union, intersection, these things. Then you have finite and infinite sets, then uncountably infinite sets or the multi sets. Then you have power sets, and the problems that come under set or the mm, solutions to these problems can be solved using uh, concepts like Venn diagram, or using principle of mathematical inclusion exclusion, or mathematical inclusion. Now, so either diagrammatic representation is used to solve the problems, or using the algebra, the problems on set can be solved. So let us see the definition. The set, what is set? A set is a collection of well-defined objects. So how it is represented? You have a set name. For example, B is a set name, and components in the set are, it is a collection of objects. So it is A comma B comma 3, A comma B comma C. So there are 3 objects in this set. The name of the set is B. So we say that it is a collection of objects A, B, and C. The object in the set are also called the elements or the members of the set. Okay, so A, B, C, these are the members. Now, in a normal set, the redundant data is not considered. For example, if you have A coming 2 times, so there is multiple entries of A. In set concept, A will be multiple occurrences of any element in the set is taken as 1. So the set is going to be A, B, C only. Now, when these multiple entries are allowed, they are called as multi-sets. So there is different there are different concepts. Now, what are the applications of set, or where the set is applicable? If you see say for example banking system, so a set will have set of all uh, bank holders account details. So account number can be the set, the name can be the set, and the city can be the set. So these various combinations can be made on the set. Now when I consider that account number, this account number is going to be unique. So the set concept says that there are unique databases. Now there are cases where multiple entries are possible. For example, if one person tries to do the transaction in ATM for withdrawing the money, so that account number entry is made twice. So such type of problems can be handled using multisets. Now, another thing is that even if the sequence, so a set contains ABC and BAC, both the sets are same. So right now what we have taught, what is learned is what is a set, how to give the name to a set. It is represented in curly brackets. Multiple entries in sets are not allowed or are not considered. The sequence in which the sets are represented, whether ABC or BAC, both represents the same set. So let us see go ahead. Now let's say that you have a set B as 2, 4, 6, 8, 10. So this is in bracket written. Now there can be set of elements in which that set of natural numbers. Then how you are going to represent? So let us see how it can be done. So multiple ways of representing set I am telling you on this slide. So if I say B is equal to 2, 4, 6, set 10. Is it a set? Yes. How many elements are there in this set? 1, 2, 3, 4, 5. So there are 5 elements in the set. Then another way of representing a set is B is equal to, so it is set name is equal to x such that this vertical line is called as such that, so all x's such that x is an even positive integer not a larger than 10. So this is another way of representing. So you can say that x is an even positive integer. So even positive integer, that means it will start from 2, 4, 6, 8 and but not larger than 10. So 10 is there, not larger than 10 means 11 is not allowed, 12 is not allowed, 10 is allowed. Okay. In general, it can be represented as x such that x possesses certain property. So a set can possess some certain property. Like set can have random numbers, set can also possess certain property. Say for example, you are trying to give set of numbers, employee numbers, or you are giving set of all the subjects. So if it is set of subjects, this is another example. So all x's such that x is a subject list for 12th standard, or it can be for final year, or it can be for PhD, and so on. So this is how the representation can be done. Then you need to understand what is empty set or the null set. Now, as I said that a set is represented using a curly bracket. If there is no element in the set, then you have a empty set and just the curly brackets. Or if you have only, it can also be represented as 5. Now, sets can be member of sets. So you can have set in a set. So you have a set uh, having first element as one more set ABC, second element as just A, third element as B, and the fourth element as the null set, which is represented using the empty curly brackets. Have you understood this? Okay. Then we say that A, B, C into curly bracket, comma A, comma B, and one null set E are the members of this set. So you can have A, then into, so how many elements are there in this set? There are 3 elements. One as A, second element as set A, and third element as set in a set A. So these are the 3 elements. So you can have multiple such elements or the sets in a set, which can be the members. Then the one more thing which is very important for us to understand is the subset and a proper subset. So let us see what is the meaning of a subset and a proper subset. P is a subset of Q. What that means? What? Suppose P is equal to 1, 2, 3, 4, 5. Okay, so P is a subset, that is a smaller set of Q. So obviously Q is the larger set. So maybe it will have 1, 2, 3, 4, 5, 6. Now you can have P as 1, 2, 3, 4, 5, and you can have Q also as 1, 2, 3, 4, 5. So that is why for subset, it is the symbol which is given is a C and then equal to. So P can be a set which is equal to Q. So it is possible that all the elements present in Q are present in a subset P. In that case, we call this as a subset. Now, when you say proper subset, this equal to sign is not present. This equal to sign is not present, and this symbol is written as only the C kind of thing. So that means this Q will have the set more than P. If P is a subset, it will have at least one element less than Q. So this is called as the proper subset. Then let us see, go ahead and see few more basics of the set. Then what is a superset? Let us learn what is a superset. Now, if I say that P is a subset, Q is the larger one is called as the superset. So we say that two sets P and Q are said to be equal if they contain same collection of elements. For example, if you have two sets, so P is equal to X such that X is an even positive integer not larger than 10. So we know that this set means 2, 4, 6, 8 and 10. And let's say what is Q? Q is a set for all x such that x plus y, x is equal to y plus z, where y belongs to 135 and z belongs to 135. Now let us see how it works. Now 1 plus 1 is going to be 2. So it will have element 2. Then 1 plus 3 is 4 and 1 plus 5 is 6. Then 3 plus 3 is also 6. As it is, you cannot have two same element occurring twice. This Q set will have only 1 6. Then it will have 10. So it will have 2 for 4, that is 3 plus 1, 4, 6 and 10. So both the elements, both the sets P and Q are the same sets, isn't it? So here I can say that P is a subset of Q or Q is a superset of P. So this is possible. Then you have a singleton set. What is a singleton set? Singleton set, in a set you have only one element. Say for example, A is equal to 1. So there is only one element in the set, that is a singleton set. Or can I say B is a singleton set, or is it an empty set? So B is an element, B is a set which is a singleton set with only single element as phi, that is a null. So you can represent this as into curly bracket phi, or it is also equal to into curly bracket into curly bracket. So this is called as the set and superset, then subset, then singleton set, or the null set. These are the things that we have learned till now. Have you all understood this? Should we proceed? Can I get feedback from you? Sir, can I get feedback
Yes.
from the students?
Yes, anyone please can give the feedback. If any doubt or any question, please you may ask now. Santosh, please
Okay.
ask the, yes, okay. If
You have
anyone,
understood.
yeah, yes, madam.
So I'll proceed now.
Yes, madam.
Now let us see what is a finite set. So a finite set is the element. Please explain superset. Okay, Santosh, let me explain you what is a superset before I start with the next concept. Now a superset is the larger set and a subset is the smaller set. Now this is the example in which I have taken where both the sets are same. Now a superset may have the larger set. For example, you have a set of natural numbers as one set and you have another set. Say, so n is equal to a set of natural numbers and P is a subset of n. So, and P contains 2, 4, 6, 8, 10. So I will say that P is a subset while as Q is the superset. Sorry, N is the superset which is set of natural numbers. So the larger one is always a superset. Or if you see the symbol of subset, this can you see my cursor? This C, this C where the open end is always at the side of open end, there is a superset, and at the place of this cup size it is the set which is written here on this side is called as the subset. Have you understood now? Santosh, have you understood? Okay,
Yes,
should we
madam.
proceed now? Santosh?
Is the Saurabh Singh, madam.
Yes.
Yeah.
Yes. Any other difficulty?
Saurabh, please
Can
tell.
you ask me the difficulty?
Madam,
I'm
if
not a
uh, you please, if anyone have any
ma'am,
difficulty,
please explain
please.
super. Okay.
Already you have explained, madam. Clear,
Okay.
madam.
Okay.
Clear.
Clear. Okay. Fine.
Okay, fine.
So let me now proceed with the next topic. So we have seen superset, we have seen subset, we have seen proper set, we have seen a singleton set, and we have seen null set. Then now we will see finite set and infinite sets. A finite set is a set in which number of elements are finite. Change the color to keep the current one, but ask me again. Don't show this message again. Okay. So A is equal to 1, 2, 3. So this is called as the finite because I can do counting of the elements in this subset. Now there can be subsets which are infinite sets. Now let us see some examples of infinite sets. So set of natural numbers, is it infinite? Because there is an infinity. Natural numbers are infinity. Set of real numbers, then all these sets are the infinite set. Then number of points on the line, yes, it is infinite. Then the concept is countably infinite and countably finite sets. So countably and uncountably infinite sets. So what do you mean by countably infinite? Where counting is possible for the infinite set, and countably infinite set means what? Where counting is not possible. Let us try to understand the difference between countably infinite sets and uncountably infinite sets. So let us say one example, set of lines, parallel lines to x-axis. Now, can there be infinite parallel lines to x-axis? Yes, there can be infinite parallel lines. If you take any two lines in between that line, there is going to be another line. Yeah, so it is countably infinite set. Now, if you consider uh, a set of points on the line between any two points, there is going to be another point in between. So it is again countably infinite. If you consider set of real numbers, so it is again countably infinite. 1.44, 1.444. Is there any number between 1.44 and 1.444? Yes, there is. There are infinite numbers between these two numbers. So such sets are called as countably infinite sets. Now, let us see what is the meaning of a set of numbers that is countably infinite. So, where counting is possible. So, we say that a set of numbers which are multiple of 5. So, there are infinite numbers which are multiple of 5, but I can do the calculations. So, 5, 10, 15. So, such type of calculations are possible. So, we say that it is countably infinite sets. So, we have seen two concepts. One is countably infinite, uncountably infinite sets and countably infinite sets. So in countably infinite set, uncountably infinite sets, counting is not possible, while as in countably infinite set, counting of the numbers is not possible, though the set contains infinite elements in the set. Have you understood this concept? Let us now proceed if you don't have any difficulty. Now, the next concept is the power set. The set of all subsets of set A is called as a power set of A. The power set of A is denoted by P of A. So, let us see what this in detail. Let's say that you have a set A with two elements A and B. So what is power set of A? It is first element is always the null set, because if you say any set union null set is going to be the same set. So phi is always an element of the set. So you always say phi as first element in the power set. So phi, that is the null element, comma, set A, first element can be a separate set, comma, B, and the combination of A and B. Or you can replace into curly bracket AB as capital A, which I have shown it in the second line. Okay, now if A is equal to A, there is only one element in this set, then how you are going to find out power set? It will have only two elements. So phi as the first element and second element as set A with element A itself. So power of A is going to be phi comma capital A. So this is how it can be done. Now, if I ask you, if I give you as A, capital A is equal to A, B, C, how many elements will be there in the power set of A with three elements? So it will be phi A, B, C, each in curly bracket, then AB, BC, and AC. So 3 into curly bracket, A comma B, B comma C, A, and so these three elements combination A comma B, B comma C, and C comma A, three elements, and another is A, B, C, A comma B comma C, that is a set A. So these are the all elements in the power set of that set. So next concept is disjoint sets. So what do you mean by two sets are disjoints? There is nothing common in between. They are called as disjoint sets. Then the concept of multiset, where multiple occurrences are possible. And there is a need in, there are applications of both, which I already told you, that a set which is occurring only where the elements are occurring only once. The example is account number. Each account holder will have a unique account number. So it is a kind of set. But if I am going to make the entries or doing the withdrawal in the ATM card, there will be multiple entries of the same account number, and each entry cannot be considered as the single entry or a joint entry, or others cannot be eliminated, because each entry is going to have different. One side, suppose I withdraw 1,000 rupees once, then it should be deducted. Then I withdraw 2,000 rupees, it should be again deducted. So each entry is important for me. So such type of entries can be handled using multisets. Then the concept is cardinality. Cardinality means count number of elements which are present in the set. So A needs to be finite, then only cardinality is possible. If A is a finite set with n distinct elements, then n is called as the cardinality of A. So cardinality of the finite sets can be counted, and it is written into two straight lines. So see how I have written over here, one straight line A and then another straight line. So this is the cardinality. So this is one example which I thought participants should solve, so that I will understand how much you have understood. Are you all ready to solve this problem? Can someone tell me, write down answers of these 5 in your notebook, or should I tell you the answer immediately so that we will not waste time? Dubey sir, can you give me suggestion, or should I wait?
Yes, anyone please can solve this, Priyanka, Sahu, Santosh.
So maybe first.
You either give me the solution, madam. One to you give the solution. Okay. Rest the student will solve, madam.
Okay. So determine whether the following statements are true or false. Can I say phi is a subset of phi? Yes, true. Since every set is subset of itself, we say that it is true. So in this problem, what is that we are going to find out? We are just trying to find out true or false. So can I say phi is a subset of phi? Yes, true. Why? Because every set is a subset of itself. Now second one, tell me whether it is a true or false. A set which having elements a comma b is a subset of this. True or false?
False.
Why false?
Because there will be C also available in next set.
No. See, this is one set.
Okay.
It contains a and b, isn't it? And
Yes.
there are two elements. So this is a subset of this superset. AB, A, comma, B, comma, C, and a set ABC. These are four elements in this superset, and I am trying to find out whether this set is a subset of this.
Subset of superset. Okay, ma'am.
Yes. So we say that true because A and B are two elements. Now, when I want to see whether it is an element, see the symbol is different. Belongs to. This is a belongs to symbol. Can I say A comma B belongs to this set? Yes, true, because A and B are contained in this. Now, if I say into curly bracket A comma B belongs to, in that case, it is going to be false because that is not the element AB. Are you getting this?
Yes,
Now,
ma'am.
yeah. Now, can I say, tell me this, whether this is true or false? D part.
I think it's
Can
false.
I say, now I am going to read it. Can I say a set with one element A comma phi is a subset of a superset with two elements A comma into curly bracket A comma phi. Now maybe you will able to answer. Is it true or false?
Ma'am, true.
Correct. So it is true. So the last one also is true because over here what I am trying to see, I am trying to see whether this element. Now in this case, this is not a set because I have written this symbol as belongs to. So this needs to be considered as element. So can I say into curly bracket A comma phi is the element of the superset. So this is the element. That's why it is true.
Yes.
I hope now the concept of set, superset is clear.
Yes.
Yes, thank you. Now, proceeding, let us see, go ahead and see operations. So you have union, intersection, then complement, then the difference and the symmetric difference. These are the basic four operations. So when you say union, the union of two sets A and B is a set of those elements that are present in set A or in set B or in both. So you call it as A union. See, the symbol of union is like U. So if I have to mathematically write this, I will say A union B is equal to into curly bracket X such that X belongs to X is what? X is an element. So all X elements such that X belongs to A or X belongs to B. So either X will be present in A or X is present in B. Then you have intersection of the two sets. Now, when I say intersection, see how what is the symbol? Symbol, you all must be aware of this symbol. So A intersection B is such that all X's such that, and sir, I'm getting some messages like someone is waiting in the waiting room. Am I supposed to do anything with that? Dubey sir?
Many are joining with us, madam. So I am allowing
Okay.
them.
I'm not, I don't have to
No,
do anything.
no. Only
Okay.
you, if anyone have a question, you please respond them, madam.
Okay. Now I want to ask you, if I have 1 hour only, then I have designed so that half an hour sets and half an hour of relations. Or should I continue in this lecture only for sets? What should I do?
This is up to you, madam. Whatever you require to explain, or you whatever you are willing, madam.
Both things are possible. Can I ask participants whether should I continue with the operations of set and continue with the concept of sets because we have limited time, or
Yes,
you
yes,
want
yes, yes.
me to understand?
Ma'am, you can do like that. You can make a part 2 concept. In this part only you can explain the motivation, or like that concept, so that the student should get interaction with us, madam.
Okay, fine. So what I will do in that case, I will tell you set operations, but without understanding basics of sets, going to relations is little difficult.
Correct.
So maybe in this lecture I will continue with sets, and if possible we can have such lecture again, separate lecture for relations.
Yeah, madam. Good. Very good.
Okay, fine. So up to 11 to 12, if 1 hour is given to me, I will continue in this lecture only with sets. Is that fine for all the participants? Or if you feel it is very basic, then I will switch to relations.
Yeah.
You can message me.
Basically, madam, in part 1 we have to explain the basics.
Okay, fine. So I will be explaining basics of sets. As soon as I realize that sets basics are over, then only I will switch to relations. I won't be spending more time on problem solving.
Yeah, madam. Yes, correct, madam.
Okay, fine. Thank you. So you have these 4 operations: set, union, intersection, complement, then difference and symmetric difference. Union and intersection I have explained you. Intersection means which are common in elements which are common in both, and that means X is an element such that X should belong to set A and X should also belong to set B. Then only it will go in the intersection part. So what is the application of this? Suppose I want to make a set of participants who belongs to state Maharashtra and who belongs to state Bhopal, from the state Bhopal. So either person will belong to Maharashtra or a person will belong to Bhopal, but I want to make a set which will have both the areas. So it will have a union. But if I say that I want to, you have 2 classes, say for example, class division A and division B, and I want elements, students which are say who knows English and maths both. So I'm going to have these 2 sets, and I will be finding out from set A all the elements who knows 2 languages. So in this case, I have to make 2 set of groups, and I have to find out whether a person A understands English and say German, 2 languages. So all those who belongs to 2 sets, English and German. Only those students will come. Okay, so this is how the intersection can be done. Then you complement. That means complement is what? First, for any set there is a universal set. Let us see the concept of universal set. So universal set means what? A superset, or suppose I am working on set A. There has to be some superset of the set A, or if there is nothing above that, then that superset is called as the universal set. So if I say U is the universal set containing set A, so that means what? The elements which are present in universal set, only those few of the elements or all the elements uh, belongs to the set A. So in that case, complement means U minus A, the elements which are present in universal set but not present in set A are called as the complement. Then what is the difference? A set of difference, we'll see example of this in each. The difference of 2 sets, set A and set B, is set of those elements that are present in set A but not present in set B. For example, if you have set A as 1, 2, 3 and set B is 1, 2, then A minus B will have the element which are not present in B but they are present in A. So A is 1, 2, 3, B is 1, 2. So element 3 is not present in B. So difference A minus B will have only one single element 3. Then symmetric difference. The difference of two sets A and B is set of elements that are present either in set A, as A minus B, or in set B minus A. And we will see this operation in detail afterwards, and it is denoted by plus in a circle. So if I have to mathematically write this each, say for symmetric difference, A symmetric difference B is equal to all x's such that x belongs to A minus B or x belongs to B minus A. This is or. So either the element can belong to A minus B or may belong to B minus A. Okay. So for the, let us see example of each of these operations. We'll do this afterwards maybe. Okay. So let's take an example for A. A is a universal set. Let's say A is a universal set and it contains elements A, comma B, comma A, comma C. So this is one element which is a small set A, comma C and a phi element. Now if I say determine the following sets. So A minus A. This set is into bracket A, single element. So what will be the answer of this? So obviously I have shown you all the answers. So one element is, as I am taking the difference, what is the difference? For set A and set B, it is a difference which are present in first set but not in second set. So from the second set, all the elements I have eliminated from A and it is written as like this. Then you have A minus AB. So AB is gone from set A and AC and phi is written. Now when I want to eliminate A minus a set having one element AC, then I will have A, B and phi. Now if I say you have a set with one element AC minus A set. Now in set A, AC is there. So AC is eliminated. In set A, there are multiple other elements, but A is subtracted from a set which will have one single element, ACs. There are no other elements. So for a difference, there is nothing remains. So the answer is phi over here. Over here, you are subtracting A comma C from a set A. Now in set A, you have A. So it won't be displayed. But in set A, there is no C. So the answer for AC minus A is going to be C. I hope you all have understood this difference.
Madam, please explain D or E more. Once more, madam. D
Okay,
and
fine.
E.
Okay, fine. I'll do that. Now in D, first set, what is the definition of difference? Difference means if A minus B, then it will have all the elements from set A but not in set B. Then it is A minus B. So in this case, that means first set is A, second set is B. So in D, the first set will have only one element. Which is that one element? It is a small set, AC. Can I say it is a set with one element, singleton element, AC? A set, AC. So it is a single element, AC. And so the good thing is that this is into curly bracket, into curly bracket. The outer curly bracket says that it is a set. What is there in that the set? It will have one single element because this is again a curly bracket, A comma C. So you are subtracting one single, you are subtracting from this set, which will have one element, a set A. Now, when you say difference, it will have all the elements which are in set A, but not in set B. Now, AC is in set A, which is subtracted. So, once this is subtracted, what remains in the first set? Nothing. That's why the answer is 5. In this E example, there are two elements in the set. AC is not element itself. There are two elements in this set, AC minus A. So A is subtracted because A is here in set A, but C is not there in this set. C is a part of the subset over here, a small set over here. So AC. If you consider the broad view of A will have, A can understand A can understand B, A can understand a small set A comma C. It will not understand elements between the small set AC. So altogether AC is one element for set A. And then you have a 5 set. So A, when you say into bracket, that is considered as subtracting one single element, and in E part there is only one curly bracket. So there are two elements. Now C was not there in A because A does not understand C. A is subtracted and C remains. This is how the subtraction is taking place. Now have you understood?
Yes, correct, madam. Correct. Thank
Yes.
you. Thank you. Okay.
Thank you. Now these are the properties of the operations. You can take a snap of these properties, and you will be needing these properties for solving the algebraic equations for the set. So for example, property of union, phi is what? Phi is the null set. Union of A union phi is A itself. Then union of A union U. What is U? U is the universal set. Obviously, what do you mean by union? Union means all the elements which are in A, all the elements which are in B. In this case, B is a universal set, and all the elements which are common in occurring only once. So we say that it is a U. So union of A union A, U is U, while as A union A bar. A bar is what? Complement of A. So all the elements which are in A and which are not in A, obviously it is going to be U, that is universal set. So these are the properties of union. Similarly, you have properties of intersection. So A intersection phi. So you are trying to take elements which are common in both. Obviously there is nothing. So phi is the only element which is common. So it is phi. A intersection union. So the answer is A, because what is common between A and union? A, because I am assuming A is a subset of union. Then A intersection A bar is phi, because there won't be anything common between the complement of A and A. Then let us see properties of A bar, that is complement. So A bar is going to be U minus A, or A bar of bar is going to be A. Then you have properties of minus. So A bar is equal to U minus A, that is complement of A are all those elements which are present in universal set but not in A, that is A bar. A minus A, subtraction of same set is phi. A minus A bar is A. I hope now you will understand this line, A minus A bar, because A bar and A both are distinct. So obviously nothing will get subtracted. That's why you get A. Then A bar minus A is also A bar, because nothing is common in both. A minus phi is A. Then A minus B is equal to A intersection B bar. This is something which you need to understand, or you need to remember. With the example, if you try to draw, then you will able to get this. Now these are three examples which are little difficult. I'll not cover it right now. Maybe you can take a snap of this PPT and try to work out with some examples which I'll be giving you afterwards. And maybe after practice, I will try to explain you these three formulas.
Okay. Madam, first property, can you explain first? First
Which
property.
one? Which
First
one,
property.
sir?
A bar is equal to.
A bar is equal to u minus a.
Yes. Only this
Okay.
explain.
Yes. So here I am explaining you the properties of minus. What is a bar? A bar is the complement. I'll see if I can use the pen. Just a minute. Okay. So I am drawing one drawing over here. So this is a set, you say U.
Yeah.
Now this universal set contains elements say 1, 2 and 3. Okay.
Okay.
And in set A contains elements 4 and 5. Now tell me what will be contained in universal set.
That is
1, 2, 3, 4, 5. All 5 are there in universal set. Please try to understand this. Okay. So universal set contains 1, 2, 3, 4, 5. All.
Correct.
Yes. Now this is a subset of A is a subset of universal set which contains two elements 4, 5. So A contains 4, 5. So A bar will contain what? Obviously, which is not there in A, that is 1, 2, 3.
2, 3. Correct.
So this is your A bar.
Okay. Fine, madam.
Okay. Try to draw A bar.
Correct.
So that's why I say that A bar is equal to U, whole U. U is
Whole
what?
U.
1, 2, 3, 4, 5.
4, 5.
Minus A, that is a set A.
Set 4, 5. Correct. Okay.
Understood?
Yes. Fine, madam.
Thank you. Maybe the same thing you can do. A minus B is this with some example. We will see how this can be done afterwards. Then you have the properties of symmetric difference. Again, this can be done. This can be proved using the Venn diagram, or this can be proved with some example. We can just write down these as this is our first lecture of sets, and then we will see how this can be done afterwards. Just remember, asymmetric difference A is phi because it is A minus B or B minus A. That's why it is phi. Then all these properties we will see examples and maybe afterwards. Then let us see algebra of set operations. So in algebra there are three properties: commutative property, associative property and distributive property. Like you have commutative property, which are various operations on mathematics: plus, minus, and star and division. These are our 4 basic operations. Similarly, on set, these are the basic operations which we have seen: union, intersection, and so on. So when you say plus is commutative, means what? A plus B is equal to B plus A. Similarly, union and intersection are commutative. That is, A union B is equal to B union A, or A intersection B is equal to B intersection A. But this difference is not commutative. A minus B is not equal to B minus A. It is obvious. Then what do you mean by associative property? A plus B plus C. If you make in plus A plus B plus C, that means 5 plus 3 plus 2. Whether you take 3 plus 2 first and you make 5 plus 3 first, every time the answer is going to be same. So over here I have used one single operation: plus 5 plus 3 plus 2. So 3 plus 2 is in bracket, so I am solving 3 plus 2 first. So 5 plus 5 becomes 10. Now if I consider 5 plus 3, that means 8, and then I add 2 to it. So I am taking first two elements first. So I am going to get the same answer. Similarly, for union and intersection, these two operations are associative. So A union B union C is equal to A union B union C. Whether you take first two operation first, first two elements first for the union, or you take next to first, is the same thing. So over here we say that the precedence matters, or the hierarchy of the operations matters. Over here I am using same symbol. So whether you take first two elements or second two elements, it is the same, but it is not same with the difference. So like you have same it with for union and intersection, it is not same with difference. If you consider simple minus operation, normal operation that we are doing, 5 minus 3 minus 2. So if you go left to right, 5 minus 3 minus 2, so answer is going to be different if I change the brackets. Similarly, over here also, a minus b minus c is not equal to a minus b minus c. This is how we can say, because when you say minus outside, this minus is multiplied by into the bracket. So minus becomes minus b minus minus plus c. So the answer changes. That's why they are not same. Now the next property, algebraic property or the identity, is a distributive property. Like you have in a into b plus c is equal to a into b plus a into c. Similarly over here for union and intersection, you have a distributive property. So if you say a union into bracket b union c, it is equal to a intersection b union a intersection c. It is same as you are doing a multiplication in a bracket. Try to understand this.
Correct.
Similarly, A union B intersection C. So union is operated over the bracket. So it becomes A union B, and then it is distributed. So you write down intersection next, and then you say A union C. So this is how the distributive property is written. Then you have some De Morgan's law, then you have idempotent law, absorption law, identity law, and domination law. Let us see what are those. So De Morgan's law is A union B bar. Like bar is multiple times written as into like this single quote. Okay, apostrophe A quote. Okay, apostrophe, or it can be written with bar. So A union B whole bar is equal to, so here what is happening? The symbols are changing. If it is union, here it becomes intersection. If it is intersection, it becomes union, and the bar is operated separately to both the elements. Now, if you feel you want to understand what it is, you can randomly take some sets A and B and try to work with this. Then you will understand. Then you have idempotent. So A union A is A intersection A is A. Then you have absorption. A union B intersection A is A, and A intersection B union A union B is A. Because A intersection B is going to be the elements which are common. Okay, say for example, you get answer as A. You take element intersection, you get answer A. Then what is going to happen? It will have A union A, answer is going to be A. Now suppose you get B. Okay, now when you say B, you are taking intersection, obviously the elements which are common in A and B are taken. So obviously A union, the common elements between A and B, every common element which is between A and B will be there in A. That's why it is B is absorbed. Similarly for the next one, when you say union of A union B, it will be even if there is all elements are not there in B, A and B are disjoint sets, then union will have both. But when you say intersection of A and this A union B, B is going to get eliminated because you are taking intersection, and answer is going to be A. So this is called as the absorption law. Then you have identity. So you take union of phi. So for me, identity for union is phi. What do you mean by identity? Identity is the value in a set which gives the same set. For example, in plus, what is the identity for plus operation? It is 0, because 5 plus 0 is going to be always 5. So 0 is the identity for plus, but 0 is not the identity for multiplication. What is the identity for multiplication? It is 1, because any number into 1 is going to be into multiplied by 1 is going to be that number. So 1 is the identity for multiplication. Similarly, for union, the identity is phi. So A union phi is A. But what will be A intersection phi? What is common? Only phi. So answer is going to be phi. So it won't be identity operation. So A intersection union is A. So identity for intersection is universal set, but identity for union is phi set. Then domination law, what you are going to dominate? If I have to dominate A with union, you have to take union with universal set. So universal set dominates union. Similarly, phi set dominates intersection, because you write any set intersected to phi, you are going to get phi only. You take any set union it with u, you are going to get u only. So these are the various rules that are useful for solving the algebraic problems. Then you have some Venn diagrams in which the problems are also solved using Venn diagram, which is the pictorial or graphical representation of the sets. Let us say two sets are disjoint sets. So you have, what is the necessary thing on which we are talking? You have universal set U in which A and B are two sets which are written. Now can I say this? Because B is a subset of U and A is also a subset of U. I'm talking about such sets. So A and B both are subsets of U. So when I say A and B, two are disjoint sets, there is nothing common between. So you say that A and B are disjoint. But if there is any common element, then the common elements are written like this. So a set is usually represented diagrammatically with a circle and a set name in this. You have to have for this set, for any universal set is written with the rectangle and you write U into it. So these two sets A and B are, there is common element, the common area is highlighted with the light blue color over here. You will see that there is common, there is overlapping between these two sets. So this is called as the common elements in between, or the which are not disjoint sets. Yes.
Yes, anyone are asking the question? No.
Okay, fine.
Okay, madam.
Yeah. Then this is the important concept. The third diagram, which second diagram, which I had said that they are common sets. Now I am showing you the example of proper set. Now over here, what is, are you understanding? B is a proper set of A. Now U is the universal set. Is A subset of U? Yes. Is B subset of U? Yes. Can I say B is a subset of A? Yes, because it is drawn inside. In addition to that, it is inside. So over here, I say that B is necessarily not equal to A. So B is inside. So it is going to be subset, but not just subset. It is a proper subset. So only one C sign is shown. There is no equal to subset sign shown over here. So this is called as the proper subset. And then if both the sets are equal, then you say AB. This is how it is written, equal subsets. So this is how the relation between two sets can be drawn. The two sets which are on same universe. Then let us see what is union and intersection in the Venn diagram. First, is, let us see what is the complement. Over here, this is the universal set which I have drawn. So this is the diagram which I am considering right now. Okay, and A is a subset of U. So inside is A part and outside is U part. And the one which does not belong to A is A bar. So this is how A and A bar are related. In the same universe, you can show A and A bar, which A bar means elements which are not there in A. That is A and A bar, complement. When you say intersection, that means common elements between A and B. So this is the colored area. Okay. Then you have the union part, A union B. The elements which are there in A, the elements which are there in B, and also the elements which are overlapping, which are there in A and B both. So this is how the union of two elements can be shown. Then A minus B, elements which are there in A, but which are not there in B. That means the common elements are also not considered over here. So this is the diagrammatic representation. Then for the symmetric difference is this or this. A only elements on in A but not in B. That so it is A minus B. A minus B, this. And what is this part? B minus A. So either it belongs to A minus B or it belongs to B minus A. This is how the diagrammatic representation of symmetric difference is shown. So let us say, suppose you have element A 1, 2, 3, 4, 5 and element set A 1, 2, 3, 4, 5 and a set B 2, 4, 6, 8. Then A intersection B means what? Common elements. So 2 is common and 4 is common. So only those will come in the intersection. Remaining will not come in the intersection part. So for A union C, can someone tell me what is A intersection C? Set A is given to you, set C is given to you.
Yes, anyone, please say the answer.
1, 3, 5.
1, 3 and 5, correct. So A and C, the common elements are shown over here. Only in A and only in C. This is how the diagrammatic representation can be shown. Then you may get some problems like using Venn diagram, prove or disprove. So that means you have to show LHS with RHS. Now let us see one example how I can draw. Let us take the simple example. A union into bracket B bar intersection C bar. Now when you are going to solve these such problems, first thing that you have to do is you will be drawing a square. You are going to assume that A, B, C, all three are subsets of some universal set. They belongs to one universal set. And you have to show that they are overlapping each other because nothing is known to you. You don't know whether they are disjoint or not. So right now you will be drawing this. So you have first first three circles, name them as 1, 2, 3. Then first bracket needs to be solved. In the bracket, first element is B bar. So whatever is there in B is a B part and whatever is not there in B bar is the B bar part. So some elements from A, some elements from C, common C. This portion which is not there in B is all comes in B bar. Now you are taking intersection of C bar. So first what you have to do, you have to see what is this C. So for me, this whole thing is C. But I am taking intersection of B bar and C. Now I know this is B bar. In that B bar, the whole C I'll take and I'll take common between this. So when I take intersection of B is whole thing. Now this portion belongs to both. So this part has come and this portion also belongs to C and B bar. So this portion comes. So this portion and this portion. And this portion will come into B bar intersection C. So this is how I have solved the first bracket. Now you are taking union with A. You are taking union with A. So first you take all A part. And then this part is union is taken. All elements in A and all elements in B bar intersection C bar. So this is what the first part I have drawn. So this is the LHS part. So I want to check whether this LHS is equal to RHS because I want to prove that. So again, I try to draw. Obviously, what is the first thing that you will be doing? I'll be taking first A union B bar, then I'll be taking A union C bar. Now, in this bracket, though you have A union B bar in first bracket, still while drawing, you will be drawing all three sets because you are working with three sets. So you draw ABC in the similar manner and you take A union B bar. What is B bar? This is known to you. This is B bar. And A union B bar. So whole part of A union B bar. So this is how it has come. I hope you have understood this. B bar means everything. Whole part. This is B bar. Isn't it? Sorry. Not this part. Not this part. So this is B bar. This whole thing is B bar. I hope you are understanding this.
Right, madam. Right.
Yeah. And then you are taking union with A. So when you say A means what? This whole thing is A. So you take union of these two, which is you get A union B bar. And then the next part is A union C. So everything in A, everything in C and common between. And then you have to take union. This is intersection. So the problem is taking intersection of these two brackets. So anything common in both. If you see this part and this part is common. So I have written this part over here. Then this part is present in this part is present in this, so this part has come. Then the common part between A and C is there. It has come because this part is present in both. And then this A part is there in first part. This A part is present over here, that's why A has come. And then this part of C has present in first, in second bracket, that's why it has come. Now, if you consider this particular part, which is present here, but it is not present here. That's why it hasn't come, because you are taking intersection. Now, if you see these two outcomes, they are same. So we say that A union B bar intersection C is equal to A union B bar intersection A union C. So this is the Venn diagram representation. The same thing you can solve using the algebraic formula. Like I have given you various rules. So you can apply those rules. Over here I can apply, say, for example, distribution. I solve this problem and obviously I will either come from left to right or right to left. So there are two methods to solve this. If I solve with Venn diagram, this is how you are going to solve. If you are going to solve with algebraic equation, either take left part or right part and try to equate it or use algebraic formulas and get it to the other side. So this is how you can prove. So you have another example over here. If I have to say, the problem is you are taking intersection of A symmetric difference B, which is equal to A intersection B symmetric difference with A intersection C. So First, try to understand what is A intersection B intersection C. So this is the first part. A intersection B. Intersection B will have only this area, A intersection B. And you have A union C. A union C will be whole part. And then you are taking difference. That means either present in A minus B or B minus C. So this is what you get, the diagram. So maybe if you try to solve using the Venn diagram, you will able to get it. Another example which I have given you to find out is A symmetric difference into bracket B intersection C is it equal to A symmetric difference B into bracket, and then you have for this bracket symmetric difference C. Now this is the property and you can prove the answer of this using the Venn diagram. Now there can be problems on the cardinality. Like you have, what do you mean by the cardinality? That is number of elements which are present in the set. So if A is a finite set with n distinct elements, then n is called as the cardinality of A, and the cardinality of A is denoted by into bracket A. So this we have already seen, and the cardinality of the phi set is 0, and because there is no element if A is phi, and if A is a subset of B, which one is the smaller one? A is the smaller one because it is subset. B is the larger one because it is to the other side of cup, so it is a larger set. So obviously the cardinality of A will be less than or equal to cardinality of B. Why equal to? Because it is a subset. It can be same also. If you say it is a proper subset, then this equal to part will not come. Now, there are some rules which we need to understand. So, if they are disjoint set, then what will be the, and you try to take the union of both of these sets, cardinality of A union B will be what? The cardinality of A and the cardinality of B, addition of that. Both are disjoint sets. So, obviously, if a element set A contains 1, 2, 3 and set B contains 4, 5, 6, so if I take union of this 1, 2, 3, 4, 5, 6, it is going to be 6 because they are distinct sets. But if the elements are common in between, they needs to be calculated only once. If I follow the same thing, A union B, where the elements are common, for example, 1, 2, 3, 4, 5 is the first set, and 5, 4, 3, 2, 5, 6, 7, 8 is another set. What is the common element? 5. So 5, 6, 7, 8, that means 4 is the cardinality of second set. 1, 2, 3, 4, 5. 5 is the cardinality of the first set. So 5 plus 4, 9. If I take union, what will be the union of these two sets? 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality is 8, not 9, because though the element contained in both the sets are different and only 5 is common. So common elements needs to be counted one in the union. That is called as the addition principle. So in a normal addition principle, if they are disjoint, the cardinality is the addition. But if there is a union, corollary for this is if all are disjoint sets, and the cardinalities of the union will be the addition of cardinality of each. Then the next thing is that I am telling you is A minus B is equal to cardinality of A minus A intersection B. So let us see what is cardinality of A minus B. First tell me what is A minus B. Can I say this is A minus B? Everything in A but not in B. So this is A minus B. I am highlighting it with a yellow color. So this is A minus B. The whole part is A, whole part is B. But this is what? All in A but not in B. So this is A minus B. What will be the cardinality of A? It will be A minus B. It will be cardinality of the elements which are only there in A but not in AB. So can I say that A minus B, that is this, cardinality of A minus B is equal to cardinality of A. That means the whole cardinality of A. So cardinality of A minus A intersection B. So whole A minus this proportion A intersection B. That becomes this part, that is A minus B. So this is how it can be proved. So A minus B, this is a very important formula. A minus B is equal to cardinality of A minus A intersection B. Similarly, from the Venn diagram, I can prove this. Then the next is called as the principle of inclusion exclusion, which is again very important. For any two elements A union B, cardinality of A union B where common things are there, for disjoint set we have seen it is addition of all the cardinals. Then what is the cardinality of A union B where there are some common elements? So it will be cardinality of A plus cardinality of B minus, because common elements will be calculated in A and B both. So it has to be subtracted once, because I want to consider common elements only once, needs to be counted only once. That's why A plus cardinality of A plus cardinality of B minus A intersection B. Okay, this is how the formula is. This is called as principle of inclusion exclusion. We can prove this, but right now I am not going to consider scope of the proof over here. If time permits and if you want, I will explain you afterwards. Now, the same thing if I want to try to proceed with the three elements. So you have now three elements A, B, C. So this is U. Then you have A, B, and C. That means what needs to be subtracted? Common elements needs to be subtracted. But when I am subtracting every time common elements, this common in 3 also is going to get subtracted thrice. So it needs to be also added. So let us see how the proof is there. A union B union C is equal to cardinality of A plus cardinality of B plus cardinality of C minus A intersection B, B intersection C, C intersection A. So all these are minus, plus this portion A intersection B intersection C. What is this portion for three sets? In between is A intersection B intersection C, that is elements which are common in all three sets. So we say, so this is the principle of inclusion exclusion with three elements. Similarly, you can have with the four elements also. Will you be able to write? Take that, this is an homework and you may try. Now, what type of problems can be solved? So you can solve problems like how many integers are there between 1 and 1000, which are divisible by 2, 3, 5 or 7. If I start counting, I need to calculate, consider each number 2, 3, 5, 7 and do the calculations. So between 1 to 1000, how many elements are there which are divisible by 2? So it has to be 1000 upon 2, that is 500. There will be 500 elements which are divisible by 2. How many elements are which are divisible by 3? So 1000 upon 3. So how much it will be 1000 upon 3? It will be something in point. But if I start calculating this number of elements, the points need not be considered. So you should take integer part of it. So it is 3, 3, and so 3, then 3 and 3. So 3, 3, 3. Okay. How many are divisible by 5? 1000 upon 5. How many are divisible by 7? 1000 upon 7. Now, if you see how many elements are there? 2, 3, 5 and 7. So which formula which I have to use is A union B union C union D. So what is that I want to find out? Which are divisible by 3, 5, 2 and 7. So A divisible by 2 union or B3, that is 5 and 7. So like I am considering cardinality of 2, 3, 5, 7 independent and 7 independently, I need to consider divisible by 3 into 2, that is 6. Then 2 into 5, 10. Then 2 into 7, 14. So how many are divisible by that? And then I have to consider with the combination of 3 also. 2, 3, 5, 3, 5, 7, and so on. And also with 3, 5, 7. So using principle of inclusion exclusion, you find out all these answers and put it in the formula and you will get the answer. Now, though this problem is very simple, the problems like this, which are word problems, are little difficult and tricky. So I am taking one problem as a last problem for today's session as far as sets are concerned, and then we may consider the next topic. So I will be telling you how you can interpret this problem. I may not solve the problem. So let us try to interpret. Let us. Yes, sir.
No, madam. It is a technical, some noise are there.
Okay,
No
okay.
one is in this.
Okay, fine. Now let us read the problem first.
Priyanka, from your side, are you want to ask anything, Priyanka? No.
Okay.
Okay.
If you understand this problem, then even solving first problem will be easy for you. It was found that in first year of computer science of 80 students. So what is the cardinality of U? What is U? First year of computer science. So when you solve such problems, you should write down what is given first. So in this case, U becomes 80. Number of students are 18. So it was found that in the first year of computer science of 80 students, 50 know COBOL. So number of people who know COBOL is 50. So cardinality of COBOL is 50. Who knows C is 55. Who knows Pascal is 46. It was also known that 37 know C and COBOL, 28 know C and Pascal, and 25 know COBOL and Pascal. 7 students, however, know none of the languages. Find how many know all the 3 languages, how many know exactly 2 languages, how many know exactly 1 language. Now, when you say exactly 1 language, that means how many know only COBOL, or how many know only Pascal, or how many know only um, C. Now, how many know exactly 2 means what? Any 2 languages. Now, over here, what is given? Is it the answer? They know for 37 know C and COBOL. But what I want to find out, how many know exactly 2 languages? Okay. So, we need to understand, because there can be some people. Now when I say how many know C or COBOL, there can be some people in this who know all 3 languages. So I cannot consider this as an answer for exactly 2 languages, isn't it? So we need to find out, or we need to understand what this problem is. Let us see what is given now. So U is 80, coordinate of B is 50, as 50 know COBOL, as 55 know C. Now when I say 50 know COBOL, it is not only COBOL. It is all those who know COBOL. In this, there can be people who know Pascal also, but that person also knows COBOL. So I am saying how many know COBOL, how many know C, how many know Pascal, how many know C and COBOL, how many know C and Pascal, how many know Pascal and COBOL. All this is given to you. And what is given as a last line? That 7 students, however, know none of the languages. So that means there are some people who doesn't know COBOL, who doesn't know Pascal, and who doesn't know C. So what is that? I will be writing cardinality of doesn't know C is complement of C, intersection, doesn't know COBOL, and also doesn't know Pascal. So complement of P, and also doesn't know, so and B, that is the B is COBOL, C is C, and P is Pascal. Okay, so when you do this, I use De Morgan's rule. C bar intersection P bar intersection B bar is equal to, I'm changing the sign from intersection to union and making cardinality complement to whole thing. So these 3 people, so I say that they know none of the languages are 7. Now what is known to me? I know the formula of A union B union C. So I say it is 7. Now, what is whole thing bar? So I know that U minus this is A union B union C. So U is 80 minus this. So 73 people know at least one language. At least one means either know only one language, or either know two languages, or either know all three languages. So what we have excluded from this, we have excluded a number of students who would know none of the languages. 7 I have excluded from the 80, and I got 73. Now 73 from this, I need to find out at least one. So how you have to form the equation? Let us see. How many know all three languages? What do you mean by all three languages? That means a student who knows C and so intersection, P and also B, that is COBOL. So it is intersection. So it is cardinality of C intersection P intersection B. Now using this formula A union B union C, what is the formula? Cardinality of A plus cardinality of B plus cardinality of C minus two sets and plus this. Now this portion I need to find out. Do I know all other things? Yes, I know all other things. So I just put it in this formula. I convert it into my variables CPB. So I say A intersection B intersection C is equal to union. So C union P union B is 73 minus all these things are known to me. I do the calculations. I get answer as 12. Similarly, how many know exactly two languages? What do you mean by exactly two? That means one language is not known. That means I want a person who knows exactly two languages, means knows COBOL and Pascal, but doesn't know B. That is sorry, C and Pascal doesn't know COBOL. Or there can be people who knows C and COBOL but not Pascal. Exactly two means there can be no C but Pascal and COBOL. So this is how you have going to find out. Now when you say A intersection C intersection P intersection B, you can combine these two parts and you will remember that you have a formula A intersection B bar is equal to A minus B. So this is the formula which I am using. Now you know what is A minus B cardinality. What is cardinality of A minus B formula? We have already seen over here, isn't it? A minus B is equal to cardinality of A minus A intersection B. Sorry. So we have solved this problem. We know this formula. So I find out from this the answer. So it is C intersection P is known to me minus B. So what is A minus B? It is A minus B bar. So I am taking this as X. One, you can call this as, sorry. So this I consider it as one element. So A minus B is A intersection. So A cardinal of A minus A intersection B. So A in this case is this. So I know each of this, I solve the answer. So this way I get one bracket. This way all two brackets can be solved and addition can be done. Then how many know exactly one language? That means know only COBOL but not Pascal and not B. So again, what you can do is This you can combine by saying, can you solve this? P union B whole thing bar. So C intersection B bar. So like you have used this formula. A intersection B bar is this minus this. Over here also you will be doing this minus this. Or this minus this. How you are done? A minus B bar. Similarly, you have C, cardinality of C minus this. And then what is this? C union into bracket P union B. This is intersection. So this needs to be distributed. So C intersection B union C intersection B. Now these two things are known to you. For taking the union also is possible for you. So this way you can solve the formula and you will able to get the answer.
Correct, madam.
Sir, I hope
Yes,
as 1
correct,
hour is
madam.
over.
Yeah.
So
Matlab,
if you want to ask me any questions, you can ask. Otherwise, as
we
1
can
hour is
stop.
over and
1 hour.
learning
Yes, madam.
mathematics for 2 hours is not a joke. So I
Yes,
will rather stop here today.
yes, madam. We will request you for the another webinar, so that you please explain the relationship also, madam.
Yes.
So
So
this time,
if you have any difficulties, you can ask me
yes.
the difficulties.
Anyone, Priyanka? Anyone, Vedang? Yes. Anyone have any doubt? Please ask. Otherwise, we can stop here. Okay. Actually, many are also joined with the video, madam.
Okay.
Because in YouTube, we are also the streaming this one. So many
Okay.
are also joined there.
So can
Anyhow,
we get the feedback from these people?
yes. I will collect and I will give you, madam.
Yes.
है ना? So I will thank you, madam, to explain this set theory, and in which you have explained the union, intersection, complement, difference, symmetric, also the properties of operation, properties of symmetric design, and the algebra for the set operation like a commutative law, associative, and a distributive. Also, you have explained very nicely the De Morgan's law, idempotence law, absorption law, identity law, then domination law. Then also you explain very much by the interactive like a Venn diagram, cardinality, and also you have explained very nicely, madam, what are the addition principle, that is for the disjoint finite number, and the principle of inclusive exclusion and the mutual inclusion. So I think students very much interactive by this your session, madam. So I will thankful for this session, and I hope we will meet very soon for the next session, madam.
Okay. Thank you, sir. Thank you
Thank
very
you,
much.
madam. Thank you. The all participants are requested to please leave now. Thank you to all.
Can I leave, sir? Hello? Can I leave, sir? Dubey, sir?